Hey everyone, welcome to my channel. Today you're going to learn about reading and analyzing DNA sequences in Python. And this tutorial I will provide you with a step-by-step tutorial along with examples and demos for a simple bioinformatics tasks such as reading and analyzing DNA sequences. I will use the Biopython library, which is a collection of Python tools for computational biology. This tutorial will cover the basics of reading, analyzing, and visualizing DNA sequences using Python library. Feel free to ask questions in the comment sections of this video, and we will explore more advanced bioinformatics tasks based on your interests and research goals. Okay, let's go on. First, install the Biopython library. Install Biopython library, you can use pip install Biopython, which is a useful library. I have previously installed this and it is already satisfied. So I go to importing. Step 2 is import Biopython library and read DNA. So first import the sequence from bio, import seq bio module, and specify the path of the file. And for example, in my case, here is the file I have located in the same directory of this Jupyter notebook. And this is a sample DNA data. And I'm going to extract and read the ID and the sequence from this pasta file, dna.pasta. This is the extension of DNA file. All right, okay, I just now specify file path. The file path is located in the same directory, so you can specify along with the extension of the file. And then you can read that sequence, read the DNA sequence, and from the pasta file, sequence record is that cfio.read, and I just pass that file path into this function and specify the type of the file that is called pasta. All right, and going to print out the sequence ID and the sequence itself. So I just pass sequence record.id obtained from this sequence record, and also print out the DNA sequence. And if there is an error, you can find that using except. Print the error in the exception, which is error. Okay, let's print out by running this cell. Yeah, the sequence ID is DNA sequence, as you can see in the file. DNA sequence, this is the ID of the DNA, and the DNA sequences are ATG, CATG, and so on. So you know about the DNA sequences as a biologist. as a Python developer, I know how to analyze the DNA sequences. So I don't mind about the meaning of each of the sequence. Okay. So far so good. And the next step 3. Step 3 is calculate the GC content. So in this case, I first import the GC fraction. And then calculate the GC. Use record dot sequence, and let's print out the result of the GC content. All right, the fraction of the GC content of the DNA sequence is 0.5, which means that is 50. If it is not fraction, actually you can use GC without fraction, but that is deprecated in the new versions of Biopython library. Yeah, it is 50, but it is now changed to GC fraction. That is equivalent to GC. That is 0.5 means 50. Right. And let's go to the step 4. The step 4 is about transcribe the DNA to RNA. To transcribe the DNA sequence to RNA, we use RNA sequence, and we have a sequence record here, so we can use that sequence record. The sequence record dot SQ dot transcribe, and it's going to transcribe that DNA sequence into RNA. Let's see the output of that. All right, the transcribed RNA sequence of DNA sequences are this one. And now you can see that this is transcribed into RNA. And the next step is going to translate RNA to protein, because we can't directly translate the DNA to protein. That's why we need to transcribe DNA to RNA. Okay. Protein sequence, RNA sequence, we have transcribed here, and we use translate method, and we print out the output to see the translated protein. So this is MAHCMH. So this is what translated sequence of RNA. So we can also perform some of the basic sequence analysis in this case. So in this step-by-step tutorial, you have seen about reading the DNA sequence, calculate the GC content, transcribe the DNA to RNA, translate RNA to protein. And next, I will show you some analysis. For example, we will count the sequence of each DNA. So I will first import counter from collections module. This is a built-in module. going to count the sequence per letter. And first, get the length of the sequence. We can use len function, which is a Python built-in function, and you can pass the sequence record in this function. And now let's count the occurrences of each nucleotide. And we can use counter function from collections module, and we pass the sequence record dot seq. Okay, let's print out and let's see the output of this code. All right, and this DNA sequence, we have 20 characters in total. And here we counted out the occurrences of each of the character in the sequence. So for example, in the DNA sequence, A is occurred 5 times, T is occurred 5 times, G is occurred 5 times, and C is occurred 5 times. Each of the character occurred 5 times according to this analysis. And next, we're going to search for motifs in the sequence. And we first define the motif. So for example, the motif in this case is sequence and ATG. So the motif is ATG in the DNA sequence. So we're going to search for motifs in the DNA sequence. So now let's search for the motif in the sequence. Positions for every, so in this case, we're going to find the position of the motif. So for, I can use list compression mechanism for for every I in the range of len sequence record was sequence, that the length of the sequence. And we use if that sequence record dot seq, we slice from I up to I plus len and pass the motif. The motif I just defined here, ATG. And every character in this motif starts from I and in this with I plus length of that motif. If that is equal, motif, then it can perform the position of motif positions. So the motif position, I specified the motif here, ATG. For example, the position of A is 0, that is the starting point in the sequence. Then the next motif is T in the sequence. And T starts from here and find the position of that T, the end of that T, for example, 0, 1, 2, 3, 4. So T is indeed at position 4 and so on. So that is the position of the motif. So you can find each of the position of the motif by specifying a motif here and calculate with this compression mechanism. So this is what analyzes the sequence. And we can also visualize the sequence of the DNA. And in this case, we can import matplots, plot, py plot as image. And we're going to plot a simple bar plot that represents each of the nucleotide counts. Delete bar, nucleotide counters. I have already found the nucleotide counters here, and I can use this one and this. And I just obtain the keys of the sequence from this count and pass then the values as a y-axis so this is what the bar chart that represents the counts of each of the nucleotide sequence. A is 5. Each of the sequence has 5 occurrences in the DNA sequence. And you can specify the x-axis, x label. And you can also specify the y label. Y label is count of each of the nucleotide. And title of the graph. Distribution. All right, this is just the distribution of the nucleotide in the DNA sequence. And next, I will show you how to save results to a text file. And that's good thing. You can output and save the result in the file for later use. So in the case, output file pass. For example, you can specify output .txt, and you can use with context manager open that file output as, and you can use write mode as file. So we output file dot write, and you can copy this and modify the GC content. And when you run this code, it will create a new file that is output.txt, and everything can be saved in that file. As you can see here, the output.txt file is created, and everything is saved in the sequence. But here to separate, you can use new line \n. It's just start with new line in each of the outputs. Yeah, you can see that sequence ID is DNA, GC content is 0.5, RNA sequence is this one, protein sequence is this one, sequence length is 20, nucleotide count is this one, and the motif position of each of the nucleotide count is this one. So this is what the output of this DNA sequence analysis and visualization tutorial. So this tutorial covers the basics of reading, analyzing, and visualizing DNA sequences using Biopython library. Feel free to expand on this examples and explore more advanced bioinformatics tasks based on your interests and research goals. Don't forget to like, share, and subscribe. Write comments below. Thanks for watching today.